In this video, I'm going to show you how Corvil's VoIP app for Splunk delivers efficient reporting and troubleshooting of VoIP performance issues. Here I've logged into Splunk and we have the Corvil VoIP app selected, and we're looking at the dashboard that ships by default. This is currently reporting in real time a number of VoIP analytics. There's a time selector here at the top where you can execute historical queries, or another query here to simply search on any call ID. The analytics in this dashboard include call volumes such as current client call requests and trends, or maximum concurrent calls observed in the system and its trend as well. Additionally, the call status is reported, including good calls, terminated calls, and failed calls, as well as all SIP singling errors observed on the wire. In the table below this is all recent calls happening currently in real time. You can quickly filter that table by clicking on any of these values up here. Let's pick 404 for example. And the table below will now report all calls experiencing 404 errors. Now to examine any of these calls in more detail, you simply click on the call and this will load Corvil's ladder diagram visualization of the full life cycle of the call. And what you see here is the source and destination of the call, the nodes involved in the call, all the messages involved in the call up until the error is observed and the call ends. As well, you can look at any of these in more detail and see a full decode of the error and the messages involved in the call. Additionally, unique to Corvil, you are only one click away from a packet capture export of this call. By clicking on the SIP here, this initiates a download of the captured SIP packets into a PCAP file. These packets have been discovered and stored on the Corvil appliance, and only the decoded contents have been published to Splunk, and this gives a link back to that and gives you one click to export packets to be shared with a third party to help troubleshoot and isolate problems like 404 errors. Now going back to the dashboard for a minute, the next table in here is ranking calls by their worst quality experience by the call. Here you can see a call that has experienced 3.41 as the MOS score. Corvil calculates this MOS score based on the real-time analysis of the media traffic, including jitter and loss of every single packet. Now to examine this call in more detail, again you simply click on the call and you're brought to the same ladder diagram visualization of the full life cycle of the call. In here we've got an invite, a trying, and we've got the RTP has been set up, and we flag the codec that's been negotiated and the ports including source and destination that the RTP traffic is flowing on. Again, you're one click and you can grab the RTP packets for this call and have a listen to them yourself in a third-party tool to verify the quality of the call. Additionally, by clicking on the link here, you are taken back to the call in the Corvil appliance itself. The reason to do this is that this passes a search to Corvil based on this call ID, and you've quickly got the full life cycle of the call shown in Corvil as well. But because Corvil has captured all the underlying packets, you can take a look at the RTP packets in detail without even exporting them for analysis. One click from here leads you to the analysis of the underlying packets. Here we've landed in the inspect data screen, and the packets have been loaded. For RTP, we're calculating a couple of key metrics like RTP jitter in both directions. Here we're seeing jitter over 200 milliseconds, which definitely impacts the quality of the call. And secondly, another key metric we report is any packets that are not marked as EF. Anything that's not marked as EF gets lumped in with the other traffic and causes queuing, which is always the underlying cause of jitter. So here we're seeing a ton of traffic not marked as EF. If you scroll down here, we've got the full decode details of the packets, including the DSCP marking. Here's a packet that's been marked as 0 rather than 46, which is equivalent to EF. And if you look at the details, in the details here, you've got the exact IP address and port numbers of the packets that are not marked correctly. So this is a simple example of how Corvil's VoIP app for Splunk can be used in conjunction with Corvil to quickly troubleshoot a VoIP performance issue with just a couple of clicks from an overall Splunk dashboard.